Bueno, hello everybody. Buenas tardes a todos. Welcome to this talk. For those of you who don't know me, my name is Graeme Rocher. I'm the founder of the Grails framework and project lead, continue to be project lead of the framework. And I work for a company called OCI. We are a full service organization who can deal with all your training and services needs. If you have Grails applications or you have trouble solving certain problems, just don't hesitate to give us a call, and we'll sort you out. In this talk specifically, I'm very excited to be launching a completely new product during the course of this presentation. And before we get to that point, though, I want to talk a little bit about how we got there, how we got to this point of creating this product, and go through a little bit of our thinking and design, and then I'll be doing some code demos. And being beta software, who knows what will happen. Hopefully the demo gods are with me, and everything works as amazingly as it should. But yeah, this is all preview stuff, but anyway, I'm looking forward to showing it to you today. So on the agenda today, like I said, we're going to talk about how we got to where we are today in the industry, how we were building apps back then, and what the challenges are today. We'll be talking about the future of application development, and we'll also be talking about Grails. So a lot has changed since 2008, 10 years ago. 10 years ago, I don't know if you've seen the tweets going around, but it was 10 years ago that we launched Grails 1.0. It's crazy to think that 10 years have passed and Grails, the first official release, is now 10 years old. Back then, things were very different, both in terms of the world as it was, and in terms of the way we were building applications. Back then, everybody was building what is commonly referred to now as the monolith application, in that it was a big deployable chunk that you typically deployed to traditional servlet containers. There were things like Angular, things like React, client-side JavaScript frameworks, and so on. Docker, even things like virtualization were in its infancy. There were no microservices as we know them today. So the whole landscape of technology was completely different back then. And in that time, we have tried to adapt. And pretty much every Java framework has been in this position of trying to adapt. And what's been happening in the industry is really that we've been trying to fit these frameworks that are really designed for monoliths into a microenvironment. Spring is even older than Grails. Was never designed for this purpose. Grails was certainly not designed for this purpose. And no matter how much marketing you hear, they were never designed for an era where you're trying to run smaller units of work in a microservices environment. So what do you do in this case? Do you, carry towing the marketing line and saying, yeah, everything's okay. You can use Grails, you can use Spring to build microservices. Or do you take a different look at the problem and go back to the drawing board? And that's exactly what we have tried to achieve. The goal is to create a new framework designed from the ground up for microservices and serverless computing in the era that we are today. And the goals are several. And some of them are contradictory. We want blazing fast startup time. You want low memory footprint. You want as small as possible jar sizes. You want zero dependencies on third-party libraries and frameworks. You want them to be 12 factors so you can externalize configuration and control your deployments. But before we could achieve this goal, we performed an analysis of Spring and Grails and the challenges to using them in microservices today. And I got to say that if anybody has analyzed the Spring and the Grails source code and the details of how they're implemented, Spring itself is an amazing technical achievement. It does remarkable things. The only problem is it does them at runtime. So these are some of the things that Spring does, and these are just a few of the things that Spring does at runtime for your code. Basically, in Spring, and of course that means in Grails as well, it's not enough to just load your classes. It needs to know your beans. It needs to know more information about them. So in order to achieve that to obtain that information, it reads your bytecode at runtime. So think about that for a second. When you deploy your application, Spring will go into your .class files at runtime, parse them into memory for each bean that you have in your application. It'll also analyze those classes and synthesize completely new annotations for each annotation on each method, on each constructor, on each field, in order to support annotation metadata. So what is annotation metadata? You know, in Spring you can apply annotations and use annotation stereotypes and have annotations that inherit behaviors from other annotations. And all of that happens at runtime. Reflective metadata. This is a huge problem when you're trying to achieve low memory consumption. There's a reason why things like Android avoid reflection altogether, because essentially reflective metadata consumes memory. It consumes a lot of memory, and it's slow. Slow in terms of invocation, slow in terms of retrieval, and it impacts startup time. The more reflective metadata that you read, the slower your application starts up. And this means is what you have is there is a direct correlation between, in a Spring or Grails project, between the number of lines of code that you have and the startup time and memory consumption. So the more lines of code you have, the slower your application will start up and the more memory it will consume. Now, you may think that this is not such a problem. In microservice, you're supposed to have less lines of code per project, right? But it's still a factor. It's still a massive factor. And the goal of trying to get Grails into a low memory environment is actually impossible based on our current architecture. Just as a reference point for this, this tweet was posted by Eric a few days ago, last week maybe. He upgraded from Grails 3.2 to 3.3 and noticed that his memory consumption went down by 1.1 gigabyte, from 1.1 gigabyte to 250 megabyte for a Grails application. The reason for this is because in Grails 3.3 we removed the ability to dependency inject domain classes. And actually we disabled it by default in Grails 3.2, and in Grails 3.3 we removed domain classes completely as dependency injection candidates. So just the fact that the dependency injection metadata that was missing caused that massive drop in memory consumption because of what, in terms of what Spring does at runtime to instrument your classes. So the micro reality is that with Spring and Grails, anything beyond Hello World becomes fat quickly. You write Hello World in Spring and you write Hello World in Grails, and yes, the memory consumption is not going to be that much. But as you build even a medium complexity app, you start to realize that you cannot fit the application into a small amount of memory, and you end up having to need basically supercomputers for each developer to run a federation of microservices. So there must be a better way, right? And I'm happy to introduce that way, and today we're launching Micronot. So what is Micronot? Micronot is designed from the ground up with microservices in mind. It's ultra lightweight and reactive based on the Netty I/O framework. It has integrated AOP and compile time DI, and it's both an HTTP server and an HTTP client. So let's see some code. Enough talk. Let's do a hello world and introduce you to Micronot. So I have a basic Micronot application here. And what we've tried to do is breed familiarity. So just like Spring Boot and Grails, you have an application class, and it can just be a Groovy script. And in this case, we have we reference the Micronot object, and when we say run, to run the application. So if I were to run this application now, and obviously it's not doing much, you can see that generally the startup time, as you can see, is 1 second. With Java, it's even faster. With Java, because Micronaut supports both Groovy and Java, we actually have around 700 milliseconds startup time with Java. For Groovy, just for the language, having a little bit slower startup time, it's around 1 second, which is still significantly better than your Spring Boot and Grails application profile in terms of startup time. But that's not very interesting. What can you actually do? So I thought, Hello World is the traditional way to introduce a new framework or tool. And there's actually quite a lot you can demonstrate with Hello World in Micronaut. So that's what I'm going to do. I'm going to write a Hello World Micronaut application. So how do we do that? Let's, first of all, create a controller called Hello Controller. There it is. And this is going to be a controller that's going to map to the root URI. And we're going to have a method called hello that takes the name of the person to say hello to. And we're going to return hello to that person. And we're going to map the action to hello / the name of the person. Oops, if I can actually spell correctly. There we go. So that's essentially a Hello World example in Micronaut. So how do we test this application? So let's write a specification. Spec. And we want to write a Spock test here. And what we're going to do is we're going to create Spock has a really nice feature which allows you to create shared objects that get auto-cleaned up. And what we're going to say is we're going to run an embedded server. And it's going to be application context.run embedded server. And then we're going to write our test hello world. So how do we call that controller? Well, like I said, Micronaut is both a client and a server. So we can actually create a hello client, and it's going to be an interface. And we're going to say that this client is mapped to the root URI. And using the same set of annotations as on the server, we're going to say string hello string name. There we go. And we're going to call that. So now we're going to say we can set it up as a shared variable here. So I'm going to say shared hello client equals embedded server application context dot get bean hello client. And now we can just say expect hello client dot hello John equals hello John. So one of the key problems we wanted to solve with Micronaut is the test execution. Test execution, so many times and drives me nuts, in Spring and Grails applications, people make the decision to use unit tests over functional tests, not because it's desirable to do so, but because functional tests are too slow to run, right? And you start mocking your infrastructure and trying to create mocks and so forth, because booting up your whole server is just far too slow. Well, with Micronaut, everything happens at compilation time. So there we go. We've implemented Hello World, and the test executes in 224 milliseconds. This is not a trick. This is the real application communicating to the real server over HTTP. If we can check that out by enabling some logging for the HTTP client, and you can see that these are real requests going back and forth between the server and the client. You can see the body, you can see everything. So hello, that's pretty cool so far. We've seen that it starts up ridiculously fast. We've seen that writing tests is super simple. But there's a whole bunch more we can demonstrate with Hello World. For one, we're returning a string here. And like I said, this is based on Netty, and surely this is like maybe a blocking operation, or maybe we shouldn't be blocking the event loop. And in fact, you can, at any moment, return from a controller a RxJava single. You can say single.just to return a reactive type, and this reactive type could be taken from a non-blocking database or non-blocking data source. And the same thing on the client. You can say single, and in here, instead of doing hello, you can say blocking get, and in this case, we have fully reactive client and server communication happening. In addition, you may want to, instead of just turning strings, you may want to say, return a JSON object. So let's create a greeting. And the greeting text is going to be that. And so now, instead of returning a string, we want to return a greeting. We can say new greeting, and the text is going to be that. And then on the client, you can use the same object to return a greeting. And now we can say get hold of the greeting and say greeting.text equals hello John. So now we're using JSON interchange between client and server. And this is fully non-blocking. We're using the Jackson asynchronous parser and Netty to encode things in a non-blocking manner for you, which is pretty cool. But obviously, you don't want to put everything inside your controller. You want some dependency injection. You may want to refactor this out into a service. So let's create a greeting service. And let's have a method that comes from the greeting service called hello. That does the same thing. And we want to inject the greeting service into our controller and say this is final. Feed it into the constructor and say greeting service or hello. There we go. Dependency injection. And dependency injection with things go wrong in demos. Here we go. We have to make sure that the bean is of type singleton, so it becomes a bean. Micronot doesn't magically know what kind of bean it is. So let's run that. See what happens. There we go. Injected greeting service directly into your controller. Dependency injection. No impact on startup time, performance. The more beans you have, you're going to see almost uniform startup time. So that's cool. That's it. That's all interesting. But microservices is more than just defining HTTP servers and clients. Yeah, there's a whole bunch of other stuff that comes into defining and creating a microservice infrastructure. So, what if I want to have multiple backend microservices and so forth? So, well, that's all possible. There is a support for various discovery services. So one of them out there is called Console. Console is a discovery server. And I have some configuration in here which I'll just uncomment and point to my console server. And if I were to run my Micronot application, run it. Hold on. No, it's actually not running. Let's start it up again. There we go. So run it. There we go. Actually, you can even see the communication because I have HTTP tracing on, the communication between the server and console as it registers itself with console. So now if we go to our console UI, you'll see that it has a single service called Hello World registered with it. There it is, happily registered. And we can run another one, so we can run two of them. If we run a second one, console now has two services for Hello World. So how do we discover these services? You've got all these back-end services. Well, what you do is you just say, in the client, you'll notice that in here I had Micronot.application.name. So you just say, you use that name in your client, and you say you want to look up, whatever, just type it. Typing is easier. So we're going to look up a client with the ID of Hello World. And now, if we run my test, you'll notice that it will, in fact, look up that service by ID, discover it automatically, and invoke the appropriate service. But of course, I've got two of them running. An interesting test would be to actually modify my greeting service over here, and let's inject the embedded server that Micronot has. We're going to inject it in there, and we're going to say this is a greeting from embedded server port, so from a particular port. Yeah. So we got two of them, and now if I run my two my two Hello World servers again. So I got two of them running, and then I go to my test here. My test. I can say hello.blockingget equals hello.blockingget. Let's see what that actually prints out. So the test failed. Why? Because I have automatic, transparent, round-robin load balancing between my two back-end microservices. So the first call to hello went to the first server. The second call to hello went to the other server, and I get two distinct responses from two different servers. Automatic, transparent load balancing without having to configure anything. It just works out of the box. But of course, there's other things you have to think about when building microservice clients. So what happens, things don't, in distributed environments, things go wrong. Sometimes a call goes wrong for no apparent reason. Networks are volatile. You need to be able to, retry operations and so forth. So how do you do that? Well, let's say retriable. Now, every time any method in this client is called, it will retry the method 3 times with a 1-second delay before ultimately failing. You can completely configure the delay, so you can say delay, I want the delay to be 100 milliseconds, and I want the attempt to be 5 before failing, and it'll do the same. It'll allow you to completely configure the retry policy. Retrying is useful, but sometimes you get to a point where if you have one of your backend services down, that essentially it can get into a situation where the client becomes overwhelmed with errors. If you have a lot of backend calls happening in your microservice environment, throwing a lot of exceptions, it can cause timeouts and instability and traffic and unneeded traffic. You don't want to keep calling this backend service if it's down for long. So you can instead apply a circuit breaker, which is the same thing as a retry. It's just stateful. What happens here now is that it'll retry 5 times, and if the services are down, it'll basically rethrow the original exception for 20 seconds before allowing a single reattempt, essentially breaking the circuit. And you might want to apply caching policies. There's a whole bunch of stuff that you may want to apply. And as you may want to be able to, you may also want to be able to externally configure these. So, for example, you may want to say, I want the hello client retry attempts to default to 3, and then in your configuration, you can go in here and say retry attempts equals 5, and reconfigure the value of that annotation. And all the metadata for the annotations and everything that happens will automatically be produced at compile time, not impacting your memory consumption. In addition to this, these annotations and the ability to configure things and so forth via annotations could become quite complex or could be common amongst different clients. So, you may want to produce annotation metadata. Well, you can do that. You can say, create an annotation called hello, and apply all of these annotations to the hello annotation. Except I created it in Java, and Java doesn't like strings, so single quoted strings, so we'll have to do that. You can apply all of these annotations to a common annotation, and you can say this is retention policy runtime, and then you can apply this annotation to your client or many different clients. And that simplifies your code base greatly. And once again, all of that annotation metadata is produced at compile time. Compile time instrumentation of your classes. That's the key. So that's, I think, is already quite a bit demonstrated in terms of Hello World, of what is possible already with Micronot. And like I said, there's a pretty compelling set of features that you can demonstrate just with a simple Hello World example. But let's look at some of the details. So how small is Micronot? Well, the smallest Hello World jar written in Java of a Micronot application is 8 megabyte. Yeah? So no more producing 35, 40 megabyte Spring Grails applications for your microservice infrastructure. They can be written, they're slightly larger when written in Groovy because Groovy has a jar file that weighs in at 4 megabytes, so not really surprising there. That's the difference. You can run a Micronaut microservice with as little as 10 megabyte max heap. Now, it is literally impossible to run a Grails or Spring application with 10 megabyte max heap. We did some testing, and a Java application with Micronaut was running with as little as 6.7 megabyte of memory. Groovy, being a dynamic language, takes a little bit more memory, but still very infinitely superior to either a Spring or a Grails application. Startup time is sub-second for Java, and around a second for Groovy. And that is linear. Obviously, that can increase slightly if you use backend persistence, but as I'll demonstrate in a minute, even with that, the startup time is blazing fast. All dependency injection, AOP, and proxy generation happens at compile time. Nothing is produced at runtime. There's no runtime reflection. There's no runtime metadata. It's all done at compile time. And it's done, how is it done? For Groovy, we support compile time, dependency injection, and AOP for Groovy, Java, and yes, even Kotlin. AST transforms are used for Groovy, and annotation processes are used for Java and Kotlin. Annotation metadata is all produced at compile time. There's the proxies that are produced at compile time, and all of the bean definitions that are produced at compile time are completely reflection-free. That means that stack traces are shorter, it's less difficult to debug. There's no reflection data caching, so your memory consumption is dramatically smaller. But like I said, if we had produced just another HTTP server, this would be not very impressive, but we've done a heck of a lot more than that. We like to call Micronaut natively cloud native, to borrow another buzzword marketing term. in that it's designed specifically for the cloud-native generation that they're calling it. It's designed from the ground up for that purpose. We have built-in service discovery with console and Eureka supported out of the box. We plan to add support for Amazon Route 53. We have built-in configuration sharing. There's no need to configure third-party things. It's just out of the box with console supported, Amazon and Google Cloud support planned. We have built-in client-side load balancing that is integrated. If you need more flexibility, we also have support for Netflix Ribbon. And we have support for serverless computing by AWS Lambda, which I'll be demonstrating in a minute, what you can do with Lambda support. And the Lambda support is only possible because of the compile time approach that we're taking. And Hello World is one thing, but you need to be able to build a heck of a lot more than Hello World to build real world applications. We're not building, nobody's building Hello World in their real jobs. So let's take a look at a more complete example. And for the official Micronot sample application that we're building, that will be released as part of the first milestone when it is released, we're building the traditional pet store approach of creating a sample application that is a pet store. And to demonstrate exactly all the various features that Micronot is capable of, this is a pretty complete and robust sample application. And I think it will provide a great reference for folks that are looking to learn the framework, learn what it's capable of, and get started. So I'm going to show you a little bit of a little tour through that sample application, and I won't have a time to show every part of the sample application, but I'll show you some of the key interesting things. So this is the pet store sample application, and it's essentially a multi-project build. And whilst I'm here, actually, I'm just going to stop console because I'm going to need to demonstrate something else. So it's made up of different sub-projects, 6 or 7 of them, and each one is a different implementation. So, for example, the comments sub-project is written in Groovy. It's using GORM for Neo4j. And comments when you like, for example, discuss or whatever, it's typical representation of graph data, right? Where you have a comment which has a reply, which has another reply, which has another reply. It's essentially a tree structure. And the Neo4j graph database work fits really well in terms of that data model. So this application is written in with Groovy, as I said, and the Neo4j graph database. And the front-end application is written with React, pure JavaScript front-end. We have various functions, which I'll come to in a minute. The mail application is sending out email using SendGrid and Amazon's mail service. The Offers application is written in Java and is using Redis as a backend database. The Pets application is written in Java as well and is using MongoDB to store information about pets. The Vendors application is written in Groovy and is using GORM with a SQL database, GORM for Hibernate. And the Storefront application is essentially the gateway that is talking to the other backend services with HTTP clients and so forth. And we also have a Docker compose.yaml. So what it effectively means is you can say Docker compose, and hopefully this goes well. You can say Docker compose /up, and it will essentially start up the entire Micronot infrastructure. And you can go to localhost 3000, which, there we go. And it's going to take a while for everything to stabilize itself because essentially the services are coming up as we're watching this application start up. So the using Docker Compose, but essentially this application is the pet store application that and you can see that we have different pets here. Oh, things are starting to come alive. What is weird is I don't have images. Let's try Chrome. Well, images are not coming up right now. But anyway, so the key thing here is that you can see that essentially that. Let me go back to my browser here. I'm going to bring it down and up again. See if we can get it working with images, which would be better. Bringing the whole thing down actually takes longer than bringing the whole thing up. But the key thing here is, this Docker Compose, it's essentially starting up the whole infrastructure, including Redis, including MongoDB. If you look at the Docker Compose.yaml, it's bootstrapping my services Neo4j, it's bootstrapping MongoDB, it's bootstrapping Redis, it's bootstrapping console, the discovery server, and then all of my backend microservices are being booted up as well. So let's see. I actually used Docker Compose up without the /d argument, so now I'm getting all the output of things happening. So there you go. Okay, so this is the pets application, and what you can see is that it's an interesting application in that in this top bit here, we're using Redis and server-sent events to essentially stream data to the browser using server-sent events in a completely non-blocking manner. Yeah, if we can go into an individual pet, and you can see that the UI is written with React, and it's React.js. And you'll notice here that we've got an area where you can request info about a particular pet via email, and you can join the discussion to post a comment. So I can say, Fred, oh, cute cat, wonderful, post a new comment. And then somebody can come in here and reply, Joe, indeed, wonderful, wonderful cat, etc. And this whole UI basically can degrade based on the services that are running. So, for example, you can say Docker Compose pause comments, and it's paused the comments application. Yeah. And now if I refresh, you see the comments are gone, but the application continues functioning. If I unpause comments, you can see that it's back. My comments application backend is back, up and running, and there it is. If your mail backend is down, you can say pause mail, and look, the mail form disappears. Your whole application is reactive and aware of things coming up, backends being down, backend microservices not being available, and it all works seamlessly. So I'm going to bring the whole thing down again because I want to show you, in particular, I want to demonstrate support for AWS Lambda. So a new trend in computing nowadays is what's called serverless computing. And serverless platforms such as AWS, Lambda, and so forth are becoming a thing. The only problem is, you can't really run Grails or Spring as a Lambda function. So how do you get productive in that environment? How do you build? And as it turns out, we discovered that producing all this compile time metadata and compile time dependency injection capability allowed us to start up Micronot ridiculously fast, which makes it a great candidate for writing serverless functions. So one of the examples here is a tweet function, and again, it's just a Micronot application. And we've added special support for writing functions as Groovy scripts. So I've got a function here called update status. And what it's going to do is it's going to update the status of a Twitter account that we have set up, post a new message to Twitter. And it's doing so with Twitter4j. And notice how, in this example, we're injecting Twitter4j by dependency injection. We've got a Twitter configuration properties, which allows, via the Twitter4j configuration builder, to configure all aspects of Twitter4j by your application configuration. We have a Twitter factory bean that constructs the Twitter4j bean that gets injected into my function. So there's quite a bit going on here. It's a real application doing real things, and it's also a function. How can this be? So how do we actually call this function? So what I'm going to do is I'm going to go into the tweet function, and you'll notice that the build has the ability has a deploy task and an invoke task, which allows you to deploy the function to AWS Lambda and invoke it. To build the application, you just create a shadow jar like anything else. And it's actually pretty neat because you can essentially invoke the function as if it was just an application. So if I do java sass jar tweet and try and run that, it's probably going to say something like, sorry, data not specified. What we can say is I'm going to post a new message. It's going to have text, and it's going to say, hello from Greach. Yeah? Forget the error logging. There's some special Lambda, AWS Lambda config that you have to have in order for functions to log properly in Lambda. So but the thing is working. So what I'm going to do is I'm going to call it, and you'll see that, look, it's posted a tweet. I've run it locally as a CLI application, and there is my hello from Greach tweet using my function. And once you've done that, you can say Gradle deploy, and I'm not going to attempt this on conference Wi-Fi. Sorry, I'm not going to deploy it, but we can probably have a go at invoking it. So let's do Gradle invoke, and this will actually invoke the real function that is running on AWS Lambda right now. And if you know how AWS Lambda works, it has a bit of a warm-up time. But once, there we go, we just tweeted again. But this time with the function that's actually running on AWS Lambda's serverless infrastructure, which is just tweeting the current time. The actual, if you look at the invoke task, it's sending the payload, which is the current time. And it tweets that, and we get it back. The first execution takes a little while longer, but once you have your warm-up done and your function is ready to roll, tweeting it again is pretty much instantaneous. Yeah. And the other thing that's pretty interesting is how you invoke functions. You can run them locally with Micronot just as normal servers and use a client to invoke them locally. And we also have special support this is in the sample application for invoking. We have a special @function client which you can apply to any interface, and it will automatically work out from the name of your method, the name of the function, and invoke it for you without. It gets implemented for you, essentially. Invokes the function on AWS, or if it's running locally, automatically discovers your function. So special support for AWS Lambda, and then as you can see, if you look at my the actual function that gets deployed, I'm actually deploying this with a memory size of 256, which is very little considering that even if you run Hello World in a normal Java application, you need a minimum of 192 megabyte on AWS Lambda. I've tested it as well with 192, and it runs as well. A little bit slower, but it runs. So you can deploy your Micronot applications to AWS Lambda. So that is the Micronot Pet Store application. There's a lot more there, and actually, yeah, that's actually one thing I wanted to show was test execution and test execution speeds. It's quite amazing. Like for example, this application here is it's using JUnit. I know it's not Spock. It looks horrible, but you know, running this test, and this test is loading up MongoDB embedded. I think it's failing because I got Mongo running in the background, but anyway, don't worry about that. It's loading up MongoDB embedded in the background. It's doing a whole bunch of stuff, and text execution speed is really fast in comparison to what you used to. These are full, functional integration tests. You don't have to be waiting for your tests to run. Okay, so yeah, the Micronot is both a HTTP server and a HTTP client. The HTTP server is fully reactive and non-blocking. We have support for React and RX Java. We have auto configuration for common databases. So, whether it be Neo4j, MongoDB, Redis, or SQL databases, we have you covered without paying the performance and memory cost associated with Spring and Grails applications. Client implementations are produced at compile time, service discovery by service ID. You get automatic client-side load balancing and fallback. I actually completely forgot to demonstrate that as part of my Hello World. Essentially, I'll just go back and demonstrate that right now. But basically, if you're in my Hello World application here, say I stopped all my servers, so I don't have any servers running, and I essentially tried to run my test here. What you would get is, an exception saying something like, right, well, let's see, hold on. Let's do hello, John. Let's tab text equals hello, John. So hold on a sec. Let me just, for the moment, return a greeting like this. Okay. Okay, so you can see that when I execute this, what I'm getting is no available exception, no available service exception, because I've got my Hello client here, and I don't have any backend services running. So you get a no available service exception. So that's a common scenario in a microservices environments is what happens when you don't have something running. So let's create a hello client fallback. And let's say this is going to be my fallback implementation. And we're going to say this fallback implements hello client. And it's going to return a new greeting that says it's going to have the text, hello, sorry, I'm not available right now. There we go. And we run that. And it's taking a bit longer to run. Remember, I applied retry policy. So it's retrying actually 3 times before failing. And you can see that this time the test still fails, but it fails because the comparison is saying, actually, I'm returning, sorry, I'm available right now. So your fallback, and it's actually a great way to test, because when you're writing tests for microservice applications, you may want fallbacks that only apply for the execution of your tests. You can see that I've created this fallback within my test Groovy directory, so you can create fallbacks specifically for your tests, and fallbacks or you can create fallbacks that are used in production, and even replace those fallbacks with ones from your test project. It makes it really trivial to deal with failover and availability issues, and you could fall back to a local cache or whatever policy you may apply. So that's pretty cool. Serverless computing, so you can write functions and run them locally or as regular server applications. You can deploy functions to AWS Lambda. After the warm-up, the functions execute in milliseconds, full dependency injection, no compromises when writing functions, no having to do halfway solutions. In terms of the roadmap, we'll be releasing the first milestones in Q2 and going GA by the end of the year. We still have a few items to do. We want to add support for Route 53, Google Metadata Service support, metrics and distributed tracing, and JBL token authentication support. But you can expect the first milestones to be out very soon. We've launched a Micronot website, so if you go to micronot.io, you will see our little mini site where you can, it doesn't have a huge amount of information on there right now, but there is a little form that you can use to gain first access and get notifications of availability. You can register at the bottom. If you have a project that is crying out for Micronot right now, you can speak to us, and we are doing pilot programs with clients, and we'd be happy to talk to you. And you can also check out Alvaro's talk tomorrow on Micronot at 9:30 a.m. I haven't had time to cover all the details of all the, he's going to go into a lot more detail in terms of dependency injection, what you can do, the behavior of the server, and so forth. I think that talk will be worth attending for folks who are interested. So, what about Grails? Grails is awesome, mature, and robust. And we love Grails, but we love it for creating, I personally love it for creating monoliths. Because not every application needs microservices, right? And also, Grails is, specific design is around, almost like, Grails would be your edge service, right? You'll want parts of Micronaut. As I said, Micronaut is both a server and a client. So you are going to want parts of Micronaut in your Grails apps. You will want to use the Micronaut HTTP client, compile time clients, and the Micronaut service discovery parts inside your Grails applications. We love Grails, and it's awesome. It's awesome in terms of what it's designed for, which is creating monolith-style applications. Grails 3.3.3 was just released as well. As I showed you in that tweet, users are seeing measured improvements in memory consumption. We have a whole bunch of more 3.3x releases plans with bug fixes and improvements going into Grails, and we also have Grails 4 on the roadmap. So Grails 4 will be released this year. It will be Java 8 minimum. It'll have Java 9 support. As soon as Groovy 2.5 is out there, it'll feature Groovy 2.5 by default. It'll be built on top of Spring Boot 2 and Spring 5. And it will have GORM 7 in tow with Hibernate 5.2 as a minimum. And we'll have awesome Micronot integration in Grails 4. So we're super, super excited about that. So, in summary, Micronot aims to provide the same wow factor for microservices that Grails did 10 years ago when it was released in 1.4 for monoliths. And even before for folks who were using the earlier point releases of Grails. Micronaut is built by the people that made Grails. You know, Grails is 10 years old, but we also have over ourselves, the team that is the Grails team, all of us, over 10 years experience in building frameworks. And we know all the problems, we know what needs to be done, and we believe that we're coming out with an awesome solution. And Micronaut is coming soon in 2018. And we have time for questions. Any questions?
Yeah. Are there any plans regarding the licensing, open source licensing, open core model?
It will be Apache licensed, open source, no strings attached.
Okay, awesome, thanks.
Same question. Okay, more questions?
Over here, yeah.
Impressive, congratulations. What about the ability to consume or produce generic REST services endpoints? I don't know, for example, Open API or Swagger specification.
So you're talking about specifications like HAL or?
Yeah.
Yeah, I mean, you can literally map. We're using Jackson as the JSON library. So you can literally map anything. The other thing as well is we're trying to eat our own dog food as much as possible with Micronaut. So that's a common phrase in technology world. So for example, you'll see if you, and you're going to see some Micronaut source code here. You'll see that for our discovery client, which is used to communicate with Eureka and console, we don't have any dependencies on any third-party libraries for that effort. So the console client itself is actually where is it? There we go. It's an abstract class. It's an add client that gets implemented for you by our own HTTP client. And the same thing with the Eureka client. So we're using Micronaut to build Micronaut, if that makes sense.
More questions?
More questions? Anybody else?
I've got a question.
Yeah.
You would be interested in using Micronaut from what you've seen.
Awesome. Okay, in that case, thanks very much, and enjoy the rest of the conference.